Hello, welcome to Mickey Techie. Learn as engineer, teach as champion. First of all, I would like to thank my family and my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, and Almighty my God, my friends, followers, my dear students and subscribers. Today, we are going to continue the engineering mechanics objective questions part 3. So that is our topic of interest. So let me start the first question about the part 3. The question is the total momentum of a system of mass, that is moving body. So mass is a moving body in any one direction remains constant unless acted upon by an external force in the direction. So this statement is called principle of conservation of momentum. Let me explain with an example. Let us consider this is a wheel of a vehicle or a car, or we can take a cycle wheel rim. If you just clog this wheel until a friction or any resistance is happen in the wheel continuously conserve the momentum. So that is the statement given above. So the answer is principle of conservation of momentum. So next, very superb question, moment of inertia of a thin spherical shell. Please make a note, thin spherical shell of mass m and radius r, about its diameter is. Here they are asking about mass moment of inertia, not an area moment of inertia. Please make a clear that. So mass moment of inertia of a thin spherical shell is 2 by 3 mr square. So option B is the right answer. And the next question, a very superb and interesting question. If the resultant of two equal forces has the same magnitude as either of the forces, then the angle between two forces is. So let me explain. So these are the forces, say P1 and P2, having a same magnitude. Let us say P1 is equal to P2, then the resultant should be in the same magnitude in this direction. Let me say it is in R, which is equal to R. Then the angle between these two forces, which is equal to 120 degree, then only all the three forces are being in equal. So here they are indirectly says about the Lam's theorem. So when the Lam's theorem is unequal, if the three forces are equal angle, then only the theorem will get an equilibrium condition. So the angle between the two forces is 120 degree. And next question is, the actual machine mechanical advantage is dash than the velocity ratio. Let me explain. If it is a theoretical machine, the mechanical advantage which is equal to the velocity ratio, whereas in actual machine there is it is not at all possible to make 100% of efficiency. Therefore, the mechanical advantage should be less than the velocity ratio. That is being correct. So the mechanical advantage of an actual machine is always less than the velocity ratio. The next question is very interesting question. Without drawing a diagram, without understanding this question, you cannot answer this, since the moment of inertia of a rectangular section having width of B and depth of D. So let me draw. So this is width of B and this is depth of D. So if the about an axis passing through the CG. So CG, let me consider CG is here. The axis parallel to the depth. So this is the depth, the axis parallel to the depth. So when the axis is parallel to the depth, the moment of inertia is, the area moment of inertia is, say, uh, db cube by 12. If the axis is parallel to the base, if the axis is parallel to the breadth, then it is called bd cube by 12. So please be clear that, so this is the axis passing through the cg and parallel to the depth. That is why it is db cube by 12. If it is a perpendicular to the depth, then it is bd cube by 12. Please make a note of this. Okay, very superb question. The maximum height of a projectile on the horizontal plane. If the this is the horizontal plane, let, let me explain. A man here is throwing a ball, so like this. The maximum height, so this is the maximum height of the projectile. So this is the maximum height of the projectile on a horizontal plane. On a horizontal plane, the maximum height is equal to u square, sine square alpha divided by 2g. So option A is the correct answer. And the next question, it is very simple question. 1 watt is equal to 1 joule per second. Next question is a moment of inertia of a square of side A about its diagonal is, about its diagonal, it is a power 4 by 12. Yes. So the maximum acceleration of a particle moving with simple harmonic motion is, this is a formula. So the maximum acceleration of a particle moving in a simple harmonic motion, the acceleration is equal to omega square r. So the omega square r is the correct answer when the particle moving with a simple harmonic motion. And next, a very interesting question. The rate of change of displacement of a body is called. Let you explain the three things. If the velocity is there, rate of change of displacement, so dl by dt. So velocity is rate of change of displacement with respect to time is the velocity, where acceleration is the rate of change of velocity with time, which is called acceleration. And if it is a jerk, the jerk j, which is equal to rate of change of acceleration with respect to time. And if it is a vibration, it is a rate of change of jerk with respect to time. So these four things you can easily understand, you can easily remember. So these are the different relationship with respect to the velocity, acceleration, jerk and vibration. So here the question is, the rate of change of displacement of a body is called, it is none other than velocity. And the next question is, the maximum mechanical advantage of a lifting machine is, the maximum mechanical advantage of the lifting machine is 1 by m. And next, a very superb question. A body of mass m moving with a constant velocity of v strikes another body of same mass moving with same velocity but in opposite direction. So this you have to remember. And constant velocity, constant masses. So this is the body 1, this is the body 2. So both have m1 and m1 and velocities of vv. So both will come in opposite direction and collides. The common velocity of a body, the common velocity of both the bodies after collision, what will happen? The bodies will tend to go outside with a velocity of 2v. So 2v are 2 times of the velocity the bodies will throw away. Next, very simple question. The center of percussion of a homogeneous rod of length L suspended at the top. So you have to make a note. Let this rod is suspended. So this rod is suspended. This is the CG. This is the CG, and the angle of percussion is just below the CG. So the length of the center of percussion is 2/3 of the length. If this is the length, so the 2/3 of the length, the angle of percussion is being happen. Next, a very superb question. The angle of inclination of a plane at, at which the body begins to move down the plane, which is called angle of friction. The term centroid is, so what is meant by a centroid? A point of application of a resultant of all forces tending to cause a body to rotate about a certain axis. So that is called a centroid. So option C is the correct one. Next, super question. A CG of a plane laminar will not be at its geometric center in case of, let you explain. If it is an equilateral triangle, so equilateral triangle, the CG and the geometric center are same. If it is a square, then CG and geometric center are same. If it is a circle, the CG and geometric center are same. But in the case of right angle triangle, the CG is different. The centroid is, or CG is different, and the geometric center is different. So this you have to notice that. Therefore, for this question, the right answer is option A, right angled triangle. Next, a super question. A rubber ball is dropped from a height of 2 meter. If there is no loss of velocity after rebounding, the ball will rise to a height of. So you have to notice the two things in this question. One is the rubber ball. So it is an elastic body. Next, there is no loss of velocity after rebounding. So after rebounding, there is no loss of velocity. Therefore, if a ball is dropped from the 2 meter height, if there is no loss of velocity, the ball again travels the 2 meter height. So there is no calculation for these type of questions. A simple questions. Once you understand the question, which is very easy to answer it. So 2 meter is the correct answer. And next question is the center of gravity of a solid cone lies on the axis at the height. The CG of a solid cone will lies on the axis at a height of 1/4 of total height above the base. So from the base, it is the base which is 1/4 of the total height. So h/4. So h/4 is the correct answer. So total height, the 1/4 of the total height. Very superb question. The periodic time t is given by, where omega is the angular velocity and velocity of a particle in radian per second. So periodic time is 2 pi by omega. 2 pi by omega. Okay, the resultant of two forces P and Q in such that P is greater than Q acting along the same straight line but in opposite direction, which is given by, so it is an opposite direction. So P minus Q is the resultant. So you can easily understand. So this is the P and this is the Q. So P and Q. P is greater than Q. So the resultant is P minus Q. The resultant is P minus Q. The next question is, when two elastic bodies collides with each other, what happen? What happen? The two bodies will momentarily come to rest after collision. Absolutely, after the collision, it momentarily come to rest since both are elastic body, and it compress at the surface of the contact, and after removal of load, it can regain its original shape. So all the three options are correct. Therefore, all the above is the right answer. Next, a superb question. Many people can make a mistake on this question. The coefficient of friction is depends upon. The coefficient of friction is only depends upon nature of the surface, not the area of contact, not the shape of the surface. Excuse me. So make this clear. Nature of the surface is very important rather than area of contact as well as the shape of the surface. So the nature of the surface is very important. So please be clear in this question. So next, superb question. The angular velocity of a body rotating in n revolutions per minute. So omega, which is equal to 2 pi n by 60, which is correct answer. So they are asking radian per second, but n is in revolution per minute. That is why we put 60 is here. If there is n is revolution per second, then omega is equal to 2 pi n. So please be clear on that. Okay, good. Next question. If a machine is having an efficiency greater than 50%, it is known as reversible machine. If the machine is less than 50%, it is called as an actual machine or non-reversible machine. If the efficiency is greater than 50%, then it is known as a reversible machine. Very superb question. The algebraic sum of moment of forces forming a couple about any point in their plane is equal to the moment of couple. Any point which is equal to the moment of couple is the correct answer. Next, you can choose which statement are correct. First, the algebraic sum of forces constituting couple is 0. Algebraic sum of forces constituting couple is 0, since you can take this as a rod, so it is fixed at the center. If there is a force of F here, if both are in opposite direction, the same magnitude, the algebraic sum of the forces which is equal to 0. And similarly, the algebraic sum of forces constituting couple at any point is same, at the any point which remains constant, and the couple cannot be balanced by a single force. If there is a force of here, okay, this is a couple, there is a force of here, it cannot balance by a single force, but can be balanced by couple of opposite sense. So the all the statements are being correct. Okay, very superb question, a ladder question. It is in the topic of friction. The heavy ladder resting on a floor against a vertical wall may not be in equilibrium if may not be in equilibrium when if both the wall as well as the surface are smooth. If any one is rough, the chance of equilibrium is high. If both are smooth, the chance of equilibrium is not at all possible. Okay. Next, a Coulomb friction is the friction between a Coulomb friction is a friction between a bodies having a relative motion. If the body is having relative motion, then only the Coulomb friction is came. Coulomb friction is came. Okay. So, this is the last question of the part 3. In which of the following is an example of lever of first order? The first order lever, they well known the example of first order lever are the arm of a machine, arm of a man, pair of a scissors, or a clinical tongs. Both all are these are all the examples of first order lever. So lever of first order. Therefore, in this option, all the above is the correct answer. So, so that is all about today's topic. If you have any doubts, please let me know in the comment section, and I will put another video for clarifying your doubts or a specific short videos for your questions. So, if you like my video, please do like, share, and subscribe. Make it a key, and it will help me to motivate. It helped me to motivate to put more videos in this area. So I hope you have all enjoyed my video. Thank you once again.